my teaching demonstration on variance and standard deviation. First thing we need to note is that we will determine how to figure out variance first because it's directly related to the standard deviation. When we do it, there are two types of problems that we need to worry about. There are the population variance and the sample variance. The difference between the two, obviously we use different symbols here. And also on the sample, we will do n minus 1 instead of n. If we have a sample one and we calculate like we would a population problem, then it won't be accurate. So it's important that we know which one we're using. So to begin, we're going to assume that I'm finding the variance for a population. I'm writing down some numbers. For example, okay, these are our numbers that will be in our population. This is our population. We have a 12, a 42, a 6, an 8, and a 17. So, an easy way to organize this information is to make a chart. And by using the population variance formula, we can make this chart. The very first thing we're going to do is make a column for x. And what x is each number in the set of our numbers. And then we'll do the symbol for our average, because that's important to calculate for this type of problem. X minus our average. And then x minus our average, and then square the entire amount. So this is what our chart will look like. So to begin, I'm going to write down our x's. We have 12, 42, 6, 8, and 17 in our first column. So in our second column, what we'll have to do is find the average of those numbers. So we have 12, 42, 6, 8, and 17. That gives us 85. And if you count, we have a total of 5 items in our list of numbers. So our average is 17. So beside every number in the x column, we will write a 17. In the next column, we're going to subtract x and the average from x. So 12 minus 17 is negative 5. 42 minus 17 is 25. 6 minus 17 is negative 11. 8 minus 17 is negative 9. And 17 minus 17 is 0. So that's how we fill out the second column of our chart. In the third column, we're going to take whatever we got in this and square it and just put that total here. So negative 25 squared is a positive 25. 25 squared is 625. Negative 11 squared is 121. Negative 9 squared is 81. And of course, 0 squared is 0. Okay, so then what we're going to do is take the numbers in our final category and total them up. So we have 25 plus 625 plus 121 plus 81. And that gives us 852. So what I've done is I've broken down how to do variance step by step. We're listing each individual step of the process. And if we look back at our population variance formula, we can see that we've done the entire first part, because to find population variance, we take the sum of x minus the average and then square that. So that's what we've done essentially in this chart. It just makes it easier to organize. So if you look, the only piece left is to divide by n. So we have 852. But what is n? N is the number of items that we have in our list of numbers. So it's 5. So if we divide 852 by 5, we get 170.4. This number is our population variance. As I said before, population variance and population deviation will be related. The relationship is that the population variance is the square of this standard deviation, and the standard deviation is the square root of the population variance. So in other words, if we take the square root of 170.4, we get 13.05. That number is our standard deviation. And we got it, like I said, from taking the square root of our variance. So that's an example of how to do variance and standard deviation with a population problem. So now, using the same numbers, let's assume that this is a sample size instead. So just as before, we'll make a chart, but we will use different symbols here. As you can see, we have n-1. Instead of using the Greek symbol, we have an x with a bar over it. It's s squared instead of this symbol squared. So the symbols are a little bit different, but it's essentially the exact same process until we get to dividing. So we have a column for x, then we'll have a column for the bar x, a column for x minus bar x, and a column for x minus bar x, all of that then squared. So those will be our columns. So once again, 12, 42, 6, 8, and 17 are our x's. And then as before, to find the average, we would add the numbers up and divide by the total number of items. So the average was 17. We'll have the same process before, subtracting bar x from the x. And we will get the same answers as before. Up to this point, nothing has changed. We're getting the exact same answers. So the next column we'll do what we did before, which is squaring what we got in our third column here. So we get the same answers, and then we will total them up, and once again we will get the same thing that we got before. Which is 852 for our total. So referring back to our sample variance formula, we'll see that we've done the first part. All that's left is to do n-1. So if we look, we know that our n is 5. So we have 852 divided by 5 minus 1, which is, in other words, divided by 4. So we will divide 852 by 4. And this time, our population variance was 213. That isn't the number we got the first time, so that shows you the difference of whether we're doing a sample or the population. So that was the sample variance. So just like before, if we want to find the sample standard deviation, we will do the square root of 213. And we get 14.59 is our sample standard deviation. For both of these problems, there's a different way that you can do it without a chart. You can find the average, which was 17, and you can write out each step of the problem if you don't like the table. And I'll show you an example of what it looks like. And we'll assume that the example I'm doing is just for population variance. So instead of doing a table, you can list each and every piece, which is what we did in table form. But if you like it better in more like a number sentence form, this is the format for that. And that works for population and sample. And that was my teaching demonstration.